Hello once again. So let's get started with this video. First off, we will create a crosshair for our character here. We will change how we are shooting things and we'll see what else. So let's go to scene view. I'm gonna put it over here so that I can watch both the scene and the game view at the same time, something like that. We need a UI image first, but I'm going to create another empty game object, which I'm going to call Crosshair Manager, and I'm going to drop the image inside, and actually I'm going to need another empty game object, which I'm just going to say extending cross and drop the image inside. I'll name this top for now, and on the inspector I'm going to give a position of 0, 0, 0, since we want it to be straight at the center. The width will make it around 2, hope you can see this, and the height around 10. Now you can't really see this because it's white, so let's give it another color. I'd prefer to leave it white, but you won't be seeing it on the video, so I'm just going to make it a red, and I'm going to make it a little bit bigger, something like height of 20. You can change it according to what you want. Okay, so I'll duplicate this 4 times and I rename. The second will be the bottom, the third will be the left, and the final will be the right. So for left and right, I'm going to change the rotation on the Z axis to 90. So we have our cross, but we don't want to just have the cross sitting in the center of the screen. We want to have a more procedural effect, and we can change it to what we want. So I will make a new script which we will call Crosshair. I will open it and I'm going to drop it inside our extended cross, not on the Crosshair Manager. Here we will put another script, and you will see later how we can, because we might want to have more crosshairs than one. Let me just close scripts from the previous videos. So let's start. Let's delete this, we will add it later. The first thing we need, although we might not use it in this video, but it's good to have it from here, it's a string which we will call crosshair name. Okay, we will use this as a tag for identifying between the crosses, so we don't add more tags than we actually need inside Unity. Next, let me just we want a public float, which is the default spread, and I'll give it something like 15. The default spread is how much it will be the parts of the cross will be apart while we are idle. We need another one, which is we'll call the maximum spread, and I'll give it the value of 50. This is how much the maximum spread we can have. The next is the wiggle spread, is how much will the cursor expand, because you might have spread but you might not have wiggle. Wiggle is when you move the cross apart. Next is a timer we will use, then the maximum timer, and let's start with our helper variables. Although this will be public and we won't have to actually assign it from the inspector, so I just hide it. But I might want to access the current spread, because we might want to offset our hit targets in case if you know how it's done in most games. If the crosshair is if somebody is running and immediately aims and shoots, his the bullets won't go straight to the target. They might have an offset. Next off, we want a private float, which is target spread, how much we want to spread, just a timer. We want a quaternion to store our default rotation, and we want a bool to help us to know if the spread is working. Next, we want a public float, which is the spread speed, and it's how fast we want the parts to be taken apart. So I'll just give it a 0.2 value. We want a rotation speed, because we will make a function to rotate the crosshair, but we might not need it. So, but anyway, we can have, or you can have it. And this is a universal script, so we might have a lot of types of crosshairs, so it's best to have all options available over here, and we can act accordingly. Some helper functions for our rotations. If you want to spread while we are rotating, I'll just give it a false. The speed we want to rotate, the spread we want to rotate, not the speed. I'll just give it a 0 for now. If we want to allow spread, some more helper functions. Let me just put it further down so that we don't confuse us. And wiggle, timer, and a timer. Now we need an array to store our parts, which we just call parts. Now of course we haven't made Crosshair parts, so this will return an error. So let's just go and create our class, which we'll call public class Crosshair part, and this will hold a public image, not image position. We're getting image position because we haven't added the namespace of Unity engine.ui, and since we are here, let's just add system because we will need it later. And now we can say public image, and we want a vector2. Let's just call it up. And now this can actually create this. This is an array of this, and we want this to be serializable. So that it saves whatever we put in the inspector. Otherwise, every time we hit play, we will actually lose all our values. So with all our variables over here, let's just go and create our helper functions. First off, we will make all these functions public in case we want to access them from any other place. First, we need an apply spread, which for each Crosshair part, we just call it IM, the name, in parts. So for each IM image, we want the rect transform and the anchor position to equals the IM up multiplied by our current spread. So for this, for every part we have over here, we take this image and multiply its anchor position by the vector2 we will put over here, and we multiply that by our current spread. Next off, we want public void, we will call wiggle crosshair, and we will say if we allow spread. And actually, before we do that, we will do another function first, also a public, and we will say change cursor spread. This will take a float which we just call value, and we will say if allow spread, and is spread working, we want it to be true. Our target spread equals our value, and the spread timer will be at 0. And on our wiggle cursor function, we will say if allow spread, change cursor spread, and we add wiggle spread, and we want the wiggle to be true. Next, we want another public function which we just call rotate cursor. This function will take a float variable we just call seconds, and we will say if allow rotating, is rotating will be true. Rotation timer equals the variable we will pass it, so the seconds, and we will say if spread while rotating, change cursor spread, and we pass the rotation speed. Now we will need an actual quotation, how do you call it? So anyway, we will do a public static float which will have us accelerate and decelerate our interpolation. This takes a float of start, this and float of end, and a float of t. Now this is pure math, so just write along. So we take the x and we subtract the end from the start. Float new t equals mathf.cos taf sin 1, and we want this to be multiplied by the pi, and this subdivided by 2 plus 0.5, and let me just make sure I have it all correct, just so I didn't forget. This is just an equation, you can Google for them online. Okay, you probably do it in school. So the x is multiplied by the new t, and we want to return a value, which that value will be the start plus x, and we want to return that value. So now that we have, let me just sit a second, okay, so that you have time to write it. This is pure math. If you don't understand what's happening, just copy paste it. So that now that we have all this, let's just go back to the top. Let's start with our start. So we want to store our default values, and the default rotation is of course transform.rotation, and the current spread equals our default spread. Next off, we want to apply the spread we have for the first time. So we say, we call the function and we pass the spread, and now we can go to update and say if is spread working, we take the timer and add to it, we subdivide it with a spread speed just so that we have more control over it. We need a new float which we'll call spread value, and we'll call our acceleration, deceleration, interpolation, and we will pass current spread, target spread, and our spread t. Next, if our spread t is greater than 1, then spread value equals our target speed, target spread, and spread t equals 0. And if we have the wiggle, we can say if wiggle timer is less than wiggle spread max timer, we can take the wiggle timer and add with time dot delta time, else wiggle timer equals 0, wiggle equals false, and target spread equals default spread. And not this, not over here. And if spread t, by the way, a cool technique you can have if in case you have big you have large if statements and you don't want to go back up every time and remember what it is, you can simply copy paste this over here as a comment so that you don't have to go up and down to find which one is it. But actually I'm going to need over here, if it's not wiggle, we want to close the is spread working. But if spread timer is less than 1, we can say change cursor spread default spread, and then of course our current spread equals our spread value, and we want to call the function to apply the spread. Next off, we can say if is rotating, so if we do what not in here, actually we want it out here, so remember, just so that we can remember later what is this large if statement. So if is rotating and a rotation timer is greater than 0, rotation timer minus equals our time dot delta time, and our transfer dot rotation equals quaternion dot Euler transform dot rotation dot Euler angles dot x. Let me just write it. Transform dot rotation transform, yes, forgot the comma over here, and that gives me a little trouble. So transform dot rotation dot Euler angles dot y, we want this to be the same, but transform dot rotation dot Euler angles dot z, we want this to be added to 360 multiplied by time dot delta time multiplied by rotation speed, and we need another parenthesis over here. So else, if our rotation time is greater is 0, we don't want to rotate, our transform dot rotation equals our default rotation, and if spread while rotating, we want to change the current cursor spread. And that's it for this script. So let's just see it in action over here. I will take the parts we created, but first, since this it might be an array, but we actually need to give it a size first before we can assign it. And you see here we have our constructors, we have our images and the vectors. So I'll drop each one inside, but I have to actually give it a value. I can't leave it 0 because we are multiplying this, so if we multiply with 0, you know, you always get 0. So for the up, I'm going to give it the 1. For the bottom will be -1 at y, for the left will be -1 at x, and for the right will be 1. And let me just see it over here, just so that we see. And as you can see, we have our crosshair over here, and because this is the default spread, it actually doesn't do anything right now. So let's see how we can utilize this inside our own game. So we will actually first we will create a script over here which we will just call Crosshair manager, and for this we will actually create a new tag which we'll call it the same Crosshair manager. Don't forget to assign it to the Crosshair manager, and just for now the only thing I'm going to have for this script is actually a public Crosshair, and which we'll call active Crosshair. We will use this script maybe on later videos. In case we want every weapon to have a different crosshair, we will use this to sort and decide which active crosshair we can use depending on our weapon. But just for now, I'm just going to drag and drop our new cursor, which by the way if you multiply this, let me close the old one, and if we go to our scene view and let's close one, and let's say I have this, and I don't want a regular cross, I want to have something like this. I think it was Crisis that had a cross like this, I don't remember. Something like this, well, a little better. So yeah, something like this failed Illuminati symbol. But if we hit play right now, you see that it actually breaks it. But because you have to assign the correct the correct values on this vector 2s. Okay, I'm not going to bother with them over here. If you want to do it, you can do it, and you can actually put even more if you want to have something like this. Whatever you want, you can just do it. Don't forget to actually add them over here and put the correct values. Okay, so this now we have a cool and procedural crosshair generator. But you can tweak it to your heart's desire. I'm just gonna delete the old one and keep the first one. And now we want to go to our camera, and let's open a camera look script. So let me just see over here. First off, we will need a public crosshair, which we'll call active crosshair. And next off, we will need a cursor crosshair offset wiggle. We give it a 0.2 value. You will see later where we use this. Now we want what is it? Yes, we want a public function which will change, we will call change crosshair, and as the name says, the only thing it will do is to change the active crosshair to the one we want. For now, we're just going to do find game object with tag, which will just call crosshair manager, and to that object we will get component crosshair manager, and we just take the active crosshair. Now there is a simpler way than this, but since we probably will changing this in later videos, just leave it like this for now. So let's create a function over here to start wiggling our so if we are fire, we want the cross to be expanding, and we can say we want it, of course, this function to be public so that we can access it from elsewhere, and we will say wiggle crosshair and camera, and we want to pass the weapon, and we want we want to pass a bool if we are shooting, and you will see later why we're doing this. But for now I'm just going to say active crosshair dot wiggle crosshair. So let's see what this does. Let's go to our user input, and here where we are shooting, instead of actually firing from our weapon manager, I'm just gonna change this. I'm just gonna comment this out, and I'm just gonna say, but let's just store it first so that we don't write a lot of stuff. And let's call it free camera look. Let's call it camera functions. And this on start, of course, we know this is on the root of our camera, so we can simply say camera.main.transform.root.get component free camera look. Instead of using tags, it's the same, since we always know this script. The free camera look will be at the root of our camera. And let's go to our input, and we can say camera functions dot how did we name it? Wiggle crosshair and camera. Wiggle crosshair camera, we want to pass, it needs a weapon, so we pass the active weapon from our weapon manager, and since we are shooting, we'll say true, although we haven't added what we will do if we are shooting, so it doesn't matter now. I don't remember which one is it for the weapon we have, so just put it for both of the weapons right now. And now if we hit play, and if we aim, and if we shoot, nothing happens. Why nothing happens? Let's see why. Yeah, because object reference not set to an instance of an object. Yeah, because we don't have an active crosshair, and we don't have an active crosshair because we haven't added. I'm doing this on start instead of awake because the object might not have yet been created of the camera, of the canvas, so I just do it in start just to be safe. So why we get an error before? Because we haven't actually added this, so we didn't have an active crosshair. Let's hit play, let's aim, let me make sure, and as you see it's a little spread since I'm firing, and you might actually let me lower the volume, but since I'm yes, we've actually lowered the we disabled the functions, the old functions we should, because we are going to change them. So I'm just lowering the volume because I'm having my speakers to lower volume, so I don't get echo anyway. So as you can see here, we can have spreading, and for both of our weapons. Of course the weapon is a little low, but you can change the values of the from over here, and to make it something that you desire, something like more that you like. So if I give it default spread of 20, let's see what it will do. Now for the pistol it might require more. You can actually change this, how much it will change. You can change it depending on the weapon. So now that we have this, let's add some more interesting stuff. So for that to happen, I'm going to add above our shoulder rotation movement so that we have it all in one place. I'm going to add a float offset X and float offset Y. We will add a new function which we'll call handle offsets, and we will say if offset X is not 0, offset X equals mathf dot move towards offset X 0 time dot delta time. So if the offset X has any value other than 0, then it will smoothly make it to have towards 0, and it's going to be the same for offset Y. And now on handle rotation movement, we can pass handle offsets, and I spelled it wrong, offsets to happen before we apply our offsets, and here we can say apply the offset to X and apply the offset to Y. And let's see how we can use this. Now we will go to our wiggle crosshair and camera, and we will say if shoot take the offset of Y and make it something like, let's give it a 3 for now. Let's go back, let's see where is the error. Oh yes, it's the same. I forgot to add. So if I now shoot, you can actually see, now that was a lot of course, but if I shoot, you can actually see the kickback from the weapon. So since this is about the weapons, we can go to weapon control, and we can add, because probably we want different weapons to have different kickback, and so we will say public float kickback, and let's just give it a value of 0.3. Let me see what I had it. Let's give it a value of 0.1 for now, and for a shotgun you will go even higher. Okay, and you can actually come over here and say, since we are passing the active weapon over here, we can say weapon.kickback, and you can even do subdivisions, multiplications. This the offsets over here, the same way you can do hit damage if somebody is hitting your own. You see more this in FPS games, where if they hit the player, the camera wiggles, and you understand. Now let me see what this did. Let's make sure both of our weapons have a value to the kickback, and they do. So if I hit play, you can actually see the nice effect, and if I keep playing, if I keep firing, you can see that actually the more I shoot, the more up we are going. So with that done, let's go shoot some stuff. Let's open up our user input, and let me see. So let's open up a user input. Let's go after update and before late update and create a new function. Let's just call it shoot ray, and over here we want the X to be the screen width divided by 2, and the Y, float Y, to be the screen height divided by 2, and this is how we get the middle of the screen. And we say array, and array will be camera.main.screen.array, new vector 3, x, y, and z of course is 0, and we want array cast hit, and this will be hit, and we want a mask, and you will see y, or maybe I'll just add it later so that you don't get confused, and we will say game object go, but of course for this we need a public float which we'll call a public game object, which we'll call bullet prefab. So over here we instantiate the bullet prefab, just give it this transform.position, dot identity, and we make it as a game object. For that bullet prefab, we're actually going to make a line renderer. So we want to access the line renderer, get component, so, and we want the start position for a line renderer to be our active weapon bullet spawn point, but we want bullet spawn point to be transformed from local to world position, so we do that with transform point vector 3.0, and we want an end position for our line, and that will be 0 for now. Next, we want to actually do a raycast, and of course we want the origin to be array, so the middle of the screen. The out hit, we want to do that into infinity. We do infinity, but you might not want to do infinity. You might want to have distance on the weapons, but in most games, depending of course on the game, weapons don't have maximal distance, since the level is actually too small for the actual bullets to reach the maximum distance. Now of course this changes from game to game. We will calculate any fall-offs for the bullet on later videos. We just don't want to mess with this right now. So what we do over here, we start a raycast from the center of the screen to see and what we are aiming, but we want to see the distance from our bullet spawn point to the hit point, and you see why we do this. And next off, we want to do a raycast hit, and which we'll call hits, and this will be an array. And why it's an array? Because we will actually do a raycast all from the position, from the gun of our character to the hit point, to where we hit from the raycast from the middle of the screen. Hope you understand. So the raycast all will be from the start position, which our start position over here is our bullet spawn point transformed from local to world position, and the direction will be the hit dot point minus the start position, and the distance will be the distance, this distance. Okay, so now that we get everything we have, we can say for each raycast hit, hit 2 in hits, and we will say if the hit 2 dot transform dot get component rigid body. So if we hit a transform that has a rigid body, we can find if we hit a collider that has a rigid body, we can actually apply force to it. We take the direction, we normalize it, and we apply the force with, as you know, add force. Now on later videos probably we will take this value, the force we actually apply to it, and we will start calculating. So because we want to shoot through stuff, so if there is a glass, it won't have any effect on the velocity of our bullet. But if we have a wooden board or a very thin wall, we want to actually have changes both to our velocity, and if there is a player behind it, we want to have to reflect that on the damage we will do to the player. But we will do this on later videos, so don't worry about it now. So else if, yeah, for now let's just give it, let's just comment this out for now and see what have we done over here. And the end position after our raycast, because even if we don't hit, we still want to have an end position. So the end position over here will always be the hit dot point, and even if we don't hit, so if the player is shooting at the sky, we still want to have an end position, and we want to get a point on array, and we just give it a great value like something like 100. And after all that, we want to have, of course, the line set position, the first position to be start position, and line dot set position 1 to be the end position. And now that we have all this, you can take the function and go over here and say shoot ray and shoot ray. Let's save this, let's go back and let's create our bullets. We want an empty game object which we'll call bullet prefab, and this object will simply have a line renderer inside. Let's see, where is it? And as you can see, this is too big for a bullet. You actually want a bullet and a trail of the bullet. So let's make it start something like 0.2, and it might be even be too much, and let's make the end something like 0.1. Let's make it 0.2 also. Let's create a material for this, which we'll call bullet, assign it, and instead of standard shader we can use something else. Let's see what we have over here. So anyway, I'll just use the standard shader for now. You can do whatever you want. I'll just give it something like this. I'll give it an emission. Let's make it something like yellow, and turn the smoothness down. Now we don't want to cast shadows, or you want, it's your choice, but I'm guessing you don't want to receive shadows. And so that's our bullet prefab. Store it inside the appropriate folder, and let's go to our third person character and to our user input and drop our bullet prefab. But of course we want to have something to shoot, so let's just make some cubes over here, and let's add some rigid body, a rigid body. Let's add some more. Let's hit play. Let me maximize that. And as you can see, we can actually shoot. But of course, you see, both our line is a little too big, and it actually stays over there. So let's go back. Where was it? Where is our bullet prefab? Over here. Let's make this a 0.01 and 0.01 or 0.03 or 2, 0.02. Let's give it something else to do. Let's make it a little less emissive so that it's not all white. And let's create a script over here which we will call auto distract. Let me open it. Where is it? We don't want, well, we want the update. So let's just call 9 numerator. Let's call it self distract, and let's do yield return new, wait for seconds. Let's make it a 0.3. So, and after that just destroy the game object. And of course you want to call this on the update or start. I don't think it's going to do much difference. So over here have it. Yes, click apply. Don't forget to apply to the prefab. Hit play, and as you see, not only we have it working, we can also shoot stuff. But of course this could happen. Now as you see, it might look that it's not actually correct, but that's the problem with a camera. So let's fix it. So I'm going to stop and maximize play. I'm going to debug aim and then hit aim and hit play. And I'm going to go to my camera, to the pivot of the camera actually. Let me just move it over here so I can fix it. And that doesn't do anything. Oh yeah, we want a pivot. You normally see on games something like this. Or this, now depending of course on the game. Now of course it might need some more, with the K we might need some more tweaking to get it exactly right, but even with a kickback and also and also the muzzle flare of the gun, which probably not a lot of people will notice that. So let's see why. Now you see, depending on the gun, it actually might look correct or might not. Let me just adjust the pivot a little bit, just to make it look a little prettier. So, but why we do it this way? Instead of the old way. First off, it has the advantage we can actually, if we do multiplayer in the future, it has the advantage we can actually pass it, instead of passing the position, so the position of every bullet from the network, you can actually pass if we hit it or not, and it's much more easier to do it with line renderers than using physics. That's why you see wacky physics on even AAA games. So let's just create a wall over here, and let's just call this wall destructible. And let's create a new layer, and let's call this layer destructible. Now we have the component on this wall, and let's open up user input, and let's go to arraycast over here. So now if I do this, you see everything behind it. Let me debug the aim. As you see here, nothing happens. The hits all go to the wall. So we have our wall into a different layer, and we can simply create a mask, an integer mask, and if you want the raycast to look for collisions on only one layer, you will only need to do bit shift the layer over here and pass the integer the mask to both our raycast and our raycast all. Actually, you don't want to do the raycast all, or we do. We'll see later. So this will only affect objects on this layer. As you can see, if I hit something else, it doesn't even register. So to do the exact opposite, to affect every layer instead, except the one we have it, which is the destructible layer, we just simply invert the bit shift for our layer. Let me see here just to make sure I didn't forget something. And I didn't, so let's move. So if you see over here right now, let me maximize it so that you can see clearer. and better. So if I aim over here, what do you think it has happened? And nothing happened, of course. And that's a problem. Let me see why. Yeah, because the layer, we haven't set it the layer. But now that we have, and we hit over here, we can see that we can actually shoot through walls, or these walls, for example. But let's say this wall had a friend, and that friend was not a wall, was a window. Of course, we want to use our fantasy and think that this is a window and not something like this. And you can say, we can go to our distractible script and say public bool distract. I don't use destroy because there is already, I don't write the name destroy because it's already used by Unity, so we might get into error. So I just try distract over here, and we want some couple game objects which we will call debris, or however you call it anyway. And over here we'll say or start for each game object geo in debris, geo.setActive to false, just in case we forgot to turn them off from the inspector. And on update we will say if distract for each game object geo in debris, geo set active to true. We don't want to be parented, so we just make it null, and after that we simply destroy this game object. Close this, save it, and let's duplicate this to something smaller. Of course you can have it parented under this so that you have more. And we got an error. Why is that? Yeah, it needs the transform instead of debris, so let's just do transform. Dot game object dot set active to true, geo dot parent equals null, and I think that was it. So as I was saying, you can actually parent this inside the glass so that you are more organized, but I'm just going to make my point across. Doesn't matter over where we place it right now, and we can go. Oh, yeah, the transform is actually an array, that's why we got an error before also, so that we have our debris over here and we can just drop them inside our list, our array at least. And now if I hit play, you see that the debris has been disabled, and if we distract the object, we actually have we don't instantiate. This is a similar technique to object pooling. Okay, so imagine this is broken glass over here. Now let's see how we can change it, how we can do this by shooting. So over here we can say else if we hit a transform which has a rigid body, we can say simply else if hit, because we might hit something completely different. So else if hit dot transform dot get component destructible. You can even put a health, so if it's a wall it won't be destroyed instantly, so you can actually subtract health from the wall also, and just say destruct equals true. Save it. Let's go back over here and let's see what we have done. Let me maximize it once again. Let me change it to the pistol. You can see, yeah, we had it the same component on our wall, and you can see where we can fire, and if we break the window we actually get debris, and we can also shoot the debris or debris, how do you call it? Anyway, let me just remove the distractible from over here since we don't want to use it. Let's see that again. As you can see, we can fire through that wall, and if we fire that wall we break it. So let's see, we're mostly done. Let me see. Oh, what the hell. Let's just make another function. So for our weapons, first off, let's go to our first weapon, or maybe actually we're nearly 1 hour and a half, so we'll just do it on the later video. We will see how we can pick up and drop weapons among some other stuff. I wanted to do it on this video, but it got more than I was expecting. So with this we change what we do. Oh yeah, before we end, let's just make another cool thing, which, as you can see here, even if I aim, even if I move, and even if I run, nothing, the cursor, the crosshair, it actually stays the same, so it doesn't actually change a lot of stuff. So let's change that, and the way we do this is open up our user input, and let me just find my cheat sheet over here, and yes, so to our user input, what we have over here, we have a horizontal and vertical axis, but we want to start declaring them outside of fixed update. So just copy paste them and remove the float from inside fixed update. Let me delete that so that we can use it and on other values, on other functions. And this, let me see, what do we, yeah, so over here we can say if horizontal is less than, yeah, we actually need another float over here which we will call offset cross, and this, comment this out, and this offset cross will actually be, where is it? Now you can set it to be either a start or update in case you want to dynamically change it from script. I'm just going to use it from on start, and we will say camera functions dot crosshair offset wiggle. So this offset for our crosshair will be the same as this somewhere over here. We added it, where was it? Will be the same as this, just so that we don't have to change it, to put the same value on two scripts. It just makes a little easier. And let's go to our fixed update, which was over here, and we will say if our horizontal is less than the offset cross, or horizontal is great, or a horizontal is greater than the offset cross, or our vertical is less than minus offset cross, or vertical is greater than offset cross. We could have just have done over here if horizontal is not equal 0, so if there wasn't any input, but we want to actually have a little more offset, and with this might be a longer if statement, but it gives us even more control over it. So if there is any movement on our horizontal, either on horizontal or vertical, we can say camera functions dot wiggle crosshair, pass our active weapon, and since we are not shooting, we don't want to apply the kickback to our camera, so save it, and let's see what we did over here. So as you can see here, if I'm shooting, if I'm standing still, there is no change in our crosshair, but if I start running, the crosshair it actually spreads. You can add greater values, you can change the speed of the crosshair. Okay, so you can change this, and if I shoot still, it's actually getting bigger and bigger. And if I aim and make fewer movements, it's actually expanding, spreading a little less. So, but in most games what you will encounter is, even if I move the mouse, it actually starts spreading, spreads the crosshair even more. So let's just add this, the last thing we will do in this video, and on our, where was it, and over here, since we have all this. Let's see, let me just see what yes, after and on our hold rotation movement, since this is also rotation, we can say if x is greater than cursor crosshair offset wiggle, or x is less than minus crosshair offset wiggle, or y is greater than crosshair offset wiggle, or y minus, or y is less than minus crosshair offset wiggle, and we say active crosshair or not active crosshair. Yeah, we have to actually, because we can't call this function since we don't store a weapon over here, so we have nothing to pass here. So we can simply just override this and call active crosshair wiggle crosshair. Stop this, save it, let's hit play, and as you can see, as I move my mouse, I'm actually expanding and spreading the crosshair apart. And if I aim, if I slowly move the mouse, you see there is no change in the crosshair. But if I move it fast, I actually move it faster. And we can shoot, we get the kickback. Now you see in many games, and especially modern games, if you shoot, there's actually no kickback in the weapon, so you can still keep shooting at the same position as you always do, which is actually horrible in my opinion. So that's it for today. We do a lot of stuff. I wanted to do some more, but we are near 2 hours. So what we do, we changed the way we shoot. We created a procedural crosshair system so that we can do a lot of stuff. You can recycle this system for the crosshair for any game you want, so that actually was pretty great. We can shoot through stuff, we can break stuff, and next time we will see what we can do. So I'll see you next week.